8th grade lesson 11.1 is parallel lines cut by a transversal. And before we go too deep into this lesson, I want to refresh our memory on intersecting lines. There were a couple of words, a couple of vocabulary words we learned when we talked about intersecting lines a while back, and I just want to dust off those cobwebs, bring them back to the front of your brain because they do come into play. We had learned that the measure of this angle and the measure of this angle would be congruent. They are the same measure. So, and we learned the name of them. The ones that are touching nose to nose in a mirror, they're in a mirror, right? So they're congruent. So you have the intersecting lines, nose to nose, with this being the noses touching. Those are going to be congruent. And those were called vertical angles. So I want to bring that vocabulary word forward. So this angle and this angle are vertical angles, so they are congruent to one another. So if this one is 130, then this one is also 130 degrees. This angle here and this angle here are also vertical angles, nose to nose in a mirror. So if this one was 60 degrees, this one would also be 60 degrees. So I wanted to bring vertical angle and congruent, meaning same size, same shape, back to the forefront of your memory. In this case, congruent meaning same measure of degrees. The other two pieces I want to put into place, or most importantly, one vocabulary word I want to put back in place too, is we had learned about complementary and supplementary angles. So here's the dusting off of cobwebs. You probably recognize those are words I've heard before, but I don't remember what they mean. So that was when if I had a straight line and it was intersected, the two angles add up to either, it's two angles put together. Either two angles add together to make a 90-degree angle, and that was complementary, or two angles will add together to make 180 degrees, and that was supplementary. And the way I remembered, I made sure my brain recognized complementary and supplementary were similar and that they are two angles that add together to something. The way I remember which is which, complementary has 1p and supplementary has double that amount. So I just had to remember if complementary makes a 90-degree angle, two angles added together make a 90-degree angle, then supplementary is double that amount. 90 plus 90 is 180, so it's two angles that add together to 180 degrees. That's how I sorted out in my brain. So supplementary angles is coming back at you in this lesson, so I wanted to bring that to the forefront. Vertical angles also coming back at you in this lesson as a tool that you will use, so I wanted to bring those back to the forefront of your brain. And so there's some more new vocabulary I'm going to add to your brains. We have these parallel lines. If you remember, parallel are two lines that will go side by side along each other and never touch. They'll just go along each other forever. So that's not a new word. Parallel lines you've remembered from before. New one is transversal. That's just a big word for a line that crosses through those parallel lines or intersects with those parallel lines, and that is called a transversal. The nice thing about that transversal is we learn all kinds of rules that help us figure out angle measures on those. So it makes it pretty easy once we learn them. The anatomy of this transversal going through these parallel lines, we have the exterior parts, meaning outside, right? They're outside. And then the interior part, the inside. We have those. And so we're going to learn 4 rules where we can figure out what the measurements are of one if we know the other. There's 4 rules that tell us that they're in fact congruent, or what their relationship is in measurement. The first one is corresponding angles, and corresponding angles will lie on the same side of the transversal, so either on the same side over here or over here, and they will be on the same side of A and B. So as an example, angle 1 and angle 5, they're both to the left of the transversal over here, and in comparison to A and B, they're both above it. So angle 1 and angle 5 would be congruent to one another. Corresponding angles are congruent to one another. let's see, another set of angles on the same side of the transversal and on the same side, the bottom part of A and the bottom part of B. Those are corresponding angles, and they would be congruent to one another. On this side, the right of the transversal, above A and above B, those are corresponding angles. They would be congruent. And to the right of the transversal and below A and below B, those would be corresponding angles, and they would be congruent. So that's one rule that we need to put into our head. Corresponding angles are congruent. And with practice, you start to recognize those corresponding angles pretty quickly. Here's another one. Alternate interior angles are also congruent. What we mean by alternate interior angles, alternate refers to being on opposite sides of the transversal, and interior means it's in the interior. So this angle 4 and angle 5, they're on opposite sides of the transversal and they're in the interior section. Those two angles would be congruent, and they look like it, right? Alternating opposite sides of the transversal, but both interior, angle 3 and angle 6, alternate interior angles, and those are congruent. Alternate exterior angles are also congruent. Alternate meaning opposite sides of the transversal, but both being on the exterior. So this is on this side of angle 1 is on this side of the transversal, exterior. Angle 8 is an exterior on this side, opposite side of the transversal. So those are congruent. And angle 2 and angle 7 are congruent. So these are congruency rules. So if I knew what the measure of angle 7 was, I could tell you based on the alternate exterior angles rule what angle 2 was. And of course I could tell you if I knew angle 7, I could tell you what angle 6 is because they're vertical angles from what we learned last year and just reviewed. All right, there's one more rule. Same side interior angles are supplementary. So the same side of the transversal, like angle 3 and angle 5, in the interior section only. So angle 3 and angle 5 are supplementary angles. Remember, that's two angles who, if you add them together, will equal 180 degrees. So if I know one of them, I can subtract that from 180 degrees to find the other one. Same over here, same side of the transversal, interior section of the parallels, angle 4 and angle 6 are supplementary. If I add them together, they will equal 180 degrees. These rules are what we're going to be putting together today to figure out how to find opposing angles or find other angles within the transversal. All right, so let's have a look at this this in use. And I didn't put the words for this. I did just put the dots showing what they stand for. Hopefully that's enough. Corresponding angles, they're same side of the transversal, same side of the A and B lines. Both are on the top. Alternate interior, they're opposite on the transversal, but they're both in the interior of the parallel lines. Alternate exterior, they're both on opposite ends of the transversal on the exterior part of the parallel lines. All of these sets would be congruent with each other. Same side interior, remember those are the interiors that are on the same side of the transversal. Those would add together to 180 degrees. So knowing those, we have angle 2 is congruent to angle 7 because they are alternate exterior angles. Alternate exterior angles 2 and 7. They're on alternate sides of the transversal in the exterior part of the parallels. And so therefore the measure of angle 2 equals 125. Oh, sorry. Measure. They wanted me to find the measure of angle 2 when the measure of angle 7 equals 125 degrees. So if this is 125 degrees, then because alternate exterior angles says that they're congruent, these alternate exterior angles are congruent, then angle 2 would be 125 degrees. So if they just gave me this one way down here, I could know that that one, based on this rule, is also the same. It's congruent. On the next one, they ask me, they say, find the measure of angle VWZ, this angle. We know that angle VWZ is supplementary to angle YVW because they are same side interior angles. This angle here is an same side interior angle with this angle here. And what we know, remember, supplementary means they both add together. to equal 180 degrees is what they say here. This says the measure of angle VWZ plus the measure of angle YVW. It looks like a bunch of gobbledygook, but that's how you read that, is equal to 180 degrees. So I can use my algebra skills and put this together. We're going to say 3x plus 6x equals 180 degrees. And now when I look at that, I'm like, oh, well, those are like terms. So let me put those two like terms together. 3x plus 6x is 9x. And I only have that one variable, and I can use inverse operations to isolate that variable. It's being multiplied by 9, so I will divide by 9. And 180 is divided by 9 20 times. 20 times 9 would give me 180. So now I know that x is 20, and if I know that x is 20, I can take this 3x. They wanted me to find the measure of angle VWZ, and it's 3 times x. Well, now I know that x equals 20, so I will plug that in instead, and 3 times 20 is 60. So it is 60 degrees. So that's how you use these to your advantage, all these rules to your advantage, to figure out, solve that puzzle of what those are, what's the missing values. It takes some practice, but you'll get the hang of it. You may need to have if this didn't work for you, written down, then maybe make some notes off of that first page where they gave all those rules. That was on page 349 where they gave all those rules. Make some notes in a version that makes sense to you of what they've explained, so that you can refer back to it. This is something you'll just need to refer to the notes until it starts to stick into your head.